Let's focus on linear systems. Very brief review. So we know a linear system just means, system in math means more than one of something. So it just means more than one linear equation at the same time. When we solve a linear system, we can get three different kinds of outcomes. We could get a single solution, right, with a single ordered pair, value of x and y. That would correspond to an intersection of the two lines if we were going to graph the two lines. We could get a result where there's no solution. That would be a situation where if I graph the lines would be parallel lines so they'd never cross. Jaden, why don't you put that away? And then the other possibility would be we get an infinite number of solutions, right? And that would be the situation like the lines overlap completely. They were the same line. So the nice thing about this is, as we're approaching the test here, you can always check, anytime you're solving for something in math, you can always check, right? So you can know before you ever even push submit on Moodle on the test, you'll be able to check your answers to see if they work, right? How do we do that? How could you know if you get the question right before you ever hit submit? Say it again. Substitute the values you found for x and y. Good, so let's try that. So let's say hypothetically, we got a solution here. We solved this system and we got a solution 312. Okay, let's check it, see if it's right. So I'll substitute into the top equation. So what's that going to give me? If I substitute those values in, what am I going to get on the left side?
4 times
12. And then on the right side, I get 4 times 3. Is that true?
Yes.
Yes, it is. Okay, good. Are we good?
Yes.
So we can move on. We know we got it right?
No, not yet.
Oh, I got to check the other one too. It's got to work for all the equations in the system, right? It's got to satisfy the entire system, which means it satisfies all the equations. So what's this one going to become on the left side?
4x.
How about the bottom line?
Oh.
If I just plug in here to see if all I'm going to do is just evaluate this and see if it's true. So y is 12 equals 1/3 times x, which is 3, plus 13. Well, what's 1/3 times 3? 1. Is 12 1 plus 13? It is not. Okay, so even though it satisfied the first equation, this solution did not satisfy the second one, and so it's not a solution of the system. If I were to graph it, what could you tell me about this point? How is it related to these two lines? I just described where I'd find this if I were to graph this point. Okay, but it didn't work for the second one. If it had worked for both, it would have been a point of intersection, but it didn't. So it's no solution. But well, they're not parallel lines either, are they? They're two lines that have different slopes. But this point right here, it satisfied the first equation, so that means it's a point that's on that line, correct? But it didn't work in the second equation, so it's not a solution of the second line. So is the point on the second line? It's not, right? It's a point that only sits on one of those lines. Okay, that makes sense? Okay, all right. So when we want to solve a linear system, let's look at the ways we can do this using algebra. So if we've got a linear system where it's easy to isolate a variable, then we can use substitution, right? Substitution is pretty straightforward and easy to do, but we only want to use it if it's easy to isolate a variable. If we can isolate a variable easily, we're going to put that equation, we're going to solve for that variable and put a box around it because that's our substitution equation. Once we isolate a variable, what do? Substitute into the other equation, and we're going to solve for the variable that gives us. And then always at the end, once we solve for one of the variables, we're going to go back and plug that in to find the other variable. Well, where do we go to plug it in? Just go to the box. Right? So let's try this. What about one like this? So we won't put this in our notebooks. We're going to get plenty of practice today. Which one of those equations should I use to create a substitution equation? Bottom one's already done. It's already solved for y, isn't it? So the very first step then is going to be to put a box around the bottom equation And I know that doesn't seem like a big deal, and it's probably not, but I really do believe it helps. And I watch people all day long, I watch people doing board work. If they remember to put a box around this, they typically don't make as many mistakes. They know right where to go. Okay, so that's my first step. I've isolated a variable. What's next? Substitute. We're going to substitute into the other equation, right? So we're going to substitute that y value into the top equation. So what's that going to give me? If I rewrite the top equation with that substitution, I'm going to get 3x minus 6 times the value I'm going to dump in there, right, is equal to what? 54. Good. And the value I'm plugging in from my substitution equation is a 2/5 x minus 8, right? Okay, so now what? What's the next step? Kai, what's the next step? I made my substitution, now what?
You distribute.
Okay, good, and that's all part of the process of solving, right? Now I've only got x's in there, so I gotta go through all the steps to solve. So one step is, first step is I probably gotta distribute that -6, right? And so that's gonna give me 3x minus, now how am I gonna do this? I know this always looks kind of intimidating, but multiplying fractions is easy. I multiply fractions straight across, right? So I've got -6, what's on the bottom? 1. -6/1 times 2/5 gives me what? -12/5. Just multiply straight across. So I get -12/5, and I've got an x there, right? And then -6 times -8 is plus 48 equals 54. Okay, so now let's think ahead here. I've got fractions. Darn it, I've got fractions. So what can I do to get rid of the fractions here? Okay, I could distribute a number through to clear the fractions. What's the number going to be? It's going to be 5, isn't it? It's always going to be the least common denominator of every fraction in the entire equation. There's only 1 this time, right? So we're going to distribute a 5 through. Now, we could do one thing that's kind of smart, though. When I'm distributing that 5 through, if I were to do it right now, if I were to just multiply everything by 5, no big deal. But look, I've got some pretty big numbers there to multiply by 5. So maybe I want to do something first.
Subtract 48.
I could subtract 48, couldn't I? Those are some like terms that I could combine. And then I'm only going to have to distribute that 5 to one thing instead of 2, right? So let's do that. Before we distribute the 5, let's combine these like terms. Let's subtract 48 from both sides. And that's going to give us 3x minus 12/5 x. Those cancel. 54 minus 48 is 6. Okay? And then we'll multiply everything by 5 because that's the least common denominator, right? Okay, now I would urge you when you're doing that, put brackets around the whole thing so you remember to distribute that everywhere. Okay? Now what if, hypothetically, what if I had 2 fractions that I needed to clear? What if one of the denominators was 5 and one of them was 3? What would I multiply by? 15. Okay? The smallest number that all the denominators divide evenly into. Okay? So if I distribute that 5, what am I going to get?
15.
Okay, good. 5 times 12/5 is going to give me the 5's will cancel, right? So I'm going to get a minus 12x equals 30. Now that's easy, right? That's no big deal. So once I get to there, now I can combine 15x minus 12x is, okay, and then so, Jaden, what's that going to give me then for x? 10, good. So x equals 10. We're most of the way there. What's my last step then? Plug it back in. Good. So the last step is we're going to plug this in up there, and that's going to give me, if I do that, I'm going to get y equals 2/5 times 10 minus 8. What's 2/5 times 10?
Wait, 20.
Yeah, good, 20 over 5, right? 20 over 5, which is 4, so I'm gonna get y equals 4 minus 8, so what's that? Good, so I got both parts of it then, right? I've got my ordered pair, what goes first?
10.
10. And then negative 4, and how would I check it? Plug it in to both equations, right? Okay, try it. Little board work. Have at it.
Is that broken?
And a little harder problem. So here we've got a linear system where substitution doesn't work, right? How come substitution's a bad idea here?
Because neither,
Raise your hand,
Neither
somebody.
is
Raise your hand. Yes, sir.
because you can't like, get rid of one of them.
I can't easily isolate a variable.
Yeah.
If I try to isolate any of those variables, I'm gonna get a bunch of fractions, agreed? Okay? So that's not something we wanna deal with. So we're gonna go to plan B, which is elimination method, right? So real quick, steps for elimination. First one usually is not a big deal, but we gotta make sure that all the equations line up. What we mean by that is if I line up the equations vertically, the x terms line up vertically, the y terms line up vertically, and the numbers line up vertically, right? So then once we're there, our goal is we wanna get opposite coefficients, so when we add the two equations up, we'll eliminate one of the variables, right? So we typically, not always, but typically we have to multiply one or both equations by some number to make that happen. Once I get there though, where I'm able to eliminate a variable, I've only got one variable left, so it's easy to solve for that. And then the last step's always the same. We're gonna plug that back in to find the second variable, right? So let's try this. Here's an example. Okay, so is everything lined up okay? Looks good. That first one, I mean, it's, usually that one's gonna be not a big deal. So we lined them up, now what? Okay, you gotta multiply by stuff. Which variable, we want to, when we're doing math at this level, as we get into more and more complex math, like you're getting into, it really helps to be strategic, kind of think ahead a little bit. Which variable should we get rid of? Y's. We multiply by smaller numbers. Okay, so we want to multiply one or both here by something so we can end up with opposite coefficients, right? So what do you suggest? What could I multiply the top equation by? Say it again, -3? Is that what I heard? Okay, -3 works. If I distribute a -3 all the way through, what am I gonna get? Positive 21x. Big number. Well, we can do this. Negative times negative is positive. What's 3 times 70? 210. What's 3 times 4? So what's 210 plus 12? 222. Okay? So what am I going to multiply the bottom one by then? If we multiply the top by -3, the bottom we need to multiply by 2, because we need to have a positive 6y, don't we? So we multiply by 2, and that's going to give us 4x plus 6y -22. If I add all those up, y's cancel. That's our goal, right? We gotta get one of the variables to cancel so we can eliminate. All right, so that gives me, what, 25x equals 200. So then, now what? Divide by 25. What's 200 divided by 25? 8. Good. Okay, so we actually took care of the next step, didn't we? We solved for that variable. We got x equals 8. Oh no, we added them, right? We added them to eliminate the variable, and we solved. We're all the way down to the bottom. What's going to be the last step? Plug it in. Which one?
2x plus 1.
Yeah, probably the bottom one. Okay. So if we do that, if we plug this guy into the bottom one, we get 2 times 8 plus 3 times y equals -11. Okay? So that gives 16 plus 3y equals negative 11. What are the two steps in order to isolate that y, solve for y? Subtract 16, so that, what's that going to give me? 3y equals 27, okay. And then divide by 3, so I get y equals negative 9. And I got it. There's both parts of my solution, x and y. Okay, what about one like this? Super easy. It's already set up, bunch of stuff already cancels. If I add everything up here, what happens? X's cancel, y's cancel. So what's left on the left side? 0. Okay. How about the right side? Okay, so how do I interpret that? If the variables go away, I'm left with a false statement. What's that telling you? What is it, Hunter? No solution. Okay. What if the variables went away and I was left with a true statement, like 0 equals 0? Infinitely many. Okay, good. All right. Let's practice one.
That was not my question.
Not like any word.
Oh, okay, I got you. Okay, last little bit, and then we'll call it quits for today. We won't finish this, but we'll get through it.
Nice one, JD.
Yes, I know, and that's exactly why we do it, because it's just, we just gotta get to the point where eventually we just think, it's no big deal.
Can I join
But
JD
it is a
too?
big deal.
But it's always a big deal, isn't it? Okay, but we can, with word problems, at least we can take some steps to make them easier, right? The big thing is with word problems and this is the most important one, you gotta define your variables. Once you define your variables, then everything just seems to flow from there. But if you don't get past that step, it's difficult to ever get started on these things. So I know it doesn't seem like much, but it is a good place to start. Right, so, and here's the thing I'll tell you about on the test, about all the application problems, so the word problems. The nice thing is, I'm gonna give you access to the Desmos graphing calculator for all of them. Oh, I think there's gonna be probably like 2 of these kind, probably, something like that. We'll go through one today, maybe, we may not get through, we'll probably get through one today, and one we'll do tomorrow. Okay, so when I have the Desmos graphing calculator though, it's super easy to solve a linear system. If I can just set it up, it'll solve it for me. I just graph the 2 lines on Desmos, and what do I look for? Intersection, right, and that's the solution, okay? But I gotta think ahead a little bit. If I'm gonna be using Desmos, which I know I'm going to solve these equations, what variables do I probably wanna pick if I'm gonna be graphing the lines? X and Y, okay? Okay, so then let's look at this one. We read through this problem. We've got this car rental companies, these two car rental companies. One of them charges a flat fee of $29.68 plus 11 cents per mile driven. Okay. Now look at that, 11 cents per mile. That looks like a rate, doesn't it? Got the word per in there, so that's probably a slope, right? That's my value for M, isn't it? Okay, the other car rental company, Penny Pincher Car Rentals, that was kind of creative. Does not charge a flat fee, right? But they charge a little higher rate, right? They've got a rate here of 39 cents per mile. So first of all, what are my variables going to be? I got to look for what's being asked, right? What are the unknowns? What are we trying to find? Miles driven, okay, right? So there's one of them. What's the other one? Okay, cost maybe, total cost, right? So then let's set those up as our variables. So in this case, we're going to be calculating a total cost. So that's the output, right? That's Y. X is going to be the input. The number of miles we drive determines what the cost is, agreed? So X equals number of miles, and Y equals cost. So now our job is, can we come up with 2 equations, because I have 2 unknowns. So we have to have enough information here to make 2 equations. Well, here's one of them. Open Road Car Rentals charges a flat fee of $29.68 plus 11 cents per mile driven. So how can I calculate the total cost of renting a car from them?
Y equals 29.68 plus 0.11x.
Okay, good. I'm gonna go ahead and put the 0.11x first, doesn't matter. Plus 29.68, either way, right? But that's my fixed cost or my flat fee or my start value, right? And there's my rate, 11 cents per mile times the number of miles, which is X. So there's one. Now what about the other one? Penny Pincher charges no flat fee, whoops, make that orange. No flat fee, but 39 cents a mile. So what's my equation there gonna be for cost?
Y equals 39x
And then plus nothing, right? There is no flat fee.
flat.
Okay, so then that's it, right? That's all we gotta be able to do. From there, we can use technology. So let's just get a quick answer, and this will be a good place to stop. Where's Desmos? Somewhere out there's Desmos. Okay, so in Desmos now, we got these two equations we're gonna input. So one of them is y equals 0.11x plus 29.68. Okay? Other one is y equals 0.39x. And then I'm just looking for the point of intersection. So it might be like if I'm zoomed all the way in, I don't see it. I just have to zoom out a bunch. And then as soon as I can see where they cross, I'm gonna highlight one of the lines until it shows me where the intersection is and click on it. So what's the solution?
106.44.
Ah, there you go, right? So the number of miles is 106. Here, I'm gonna take a picture of this. I know. Oops, there we go. Okay, so there's that's all we need. We use Desmos, and our solution is how many miles? 106. Right, so how am I gonna get there? I gotta go. It's like one of those little mazes, you know? 106 miles. And how much am I charging? Each company is charging $41.34 after that many miles.
Yes.
Okay, there's the two parts, right? Make sense?
Yep.
Okay. Peace. We'll do one more of those tomorrow. Actually, we won't. I'll be gone on Thursday. And then we'll do a quick review of the inequality stuff, and you'll be all ready to roll for Friday.